In this topic, I'd like to talk to you about encryption algorithms. Now, we're going to cover a little bit about algorithms, but as you'll see throughout our discussion on cryptography, you're going to learn more and more about them beyond this particular session. Now, encryption algorithms can be roughly divided into three categories: symmetric algorithms, asymmetric, and hashing. Now, we haven't talked about hashing as of yet. We're going to talk about that a little bit later. So we're going to shelve the discussion on the hashing algorithms until another session. So for now, let's focus on symmetric and asymmetric. And you already know what symmetric key and asymmetric key cryptography are. Symmetric key obviously uses one key that encrypts and decrypts, and asymmetric uses a public and private key system. Each of these methods have their different strengths, weaknesses, and uses in cryptography. Algorithms, as we know, can also be divided into streaming or block ciphers, and they're used in various applications as well. Now, some of the algorithms that we'll talk about are considered to be weak or broken, or may just not be typically used because they've been replaced by stronger algorithms. You still may need to know them for the exam so that you'll know which ones you shouldn't use, or if you're a hacker, which ones you would be best to target. So in some cases, algorithms are actually very strong, but their implementation method is weak. Maybe it's a good algorithm, but it was not implemented in the system properly. So hackers will target that as well. Now, let's talk about encryption algorithms from a general perspective first. Encryption strength is based upon really two key factors: the strength of the key and the strength of the algorithm. The key strength itself refers to the length and complexity of the key. Now, obviously, a single character password isn't as strong as an 8-character password. So length is a factor there. And obviously having a password that's all lowercase letters is not as strong as having a password that's uppercase, lowercase, special characters, and numbers and so forth. So complexity comes into play there too. Now, algorithm strength relates to the mathematical complexity of the algorithm itself, and that could be elliptic curves, it could be large prime numbers, it could be all kinds of different mathematical algorithms or formulas. The stronger the algorithm, the stronger the encryption. The stronger the key, the stronger the encryption. Now, there are also weaknesses and strength of the various methods and algorithms that are implemented, and we can discuss those a little bit as we go through the course. Now, I mentioned that algorithms are divided into symmetric, asymmetric, and hashing, and we're going to talk about the hashing a little bit later. But you can also classify them as block or streaming. So let's talk about which ones are symmetric and which ones are asymmetric and which ones are block and which ones are streaming. Now, it's easy to pick out the streaming one. That's RC4. And to be perfectly honest, in most certification exams you take, most cryptography discussions are really going to mention RC4 as basically the only streaming algorithm you need to concern yourself with. And RC4 has one particular interesting use. It's used in WEP. And one of the reasons that WEP in wireless communications is so weak and easily broken is not because RC4 is a weak algorithm, it's because it was implemented poorly. So that makes WEP easy to crack. RC4, along with the rest of these in these charts, are symmetric algorithms. Now, obviously, we have old DES, the data encryption standard, which was very weak and easily cracked. Then we had triple DES, which 3 times the basic key size and rounds of encryption, but still easily broken. Triple DES is not used widely much anymore, except in some cases to encrypt DVDs. And unfortunately, it's easily broken. AES is the data encryption standard of the United States right now, and it comes in key sizes of 128 bits, 192 bits, and 256 bits. Now you'll notice in the third column for type, all of these that I'm talking about are blocks except RC4. So it's worth mentioning once again that RC4, you see it on the exam, is the only streaming cipher you'll probably see. There's also other ones like IDEA, Twofish, Blowfish, and RC5. Now let's move on to asymmetric algorithms, and there's only a few you really need to worry about for the exam or really in real life. There's RSA, which has a key size of 512 bits, and it's, again, primarily used for encryption. One thing about RSA algorithm, since we're talking asymmetric, that's the main algorithm that's used in public and private key cryptography. So to develop and use a digital certificate and a public and private key pair, we use RSA. There's also ECC, which is elliptical curve cryptography. and it has a variable key size, and it's used for encryption. One thing about ECC, and this is, again, you might see this on an exam somewhere, is that it requires very low computing power. And this makes it ideal for mobile devices like tablets and smartphones. So you might see a description of ECC tied to those types of devices. And in fact, its key length and the way it actually does its keys is such that even a 128-bit key with ECC is equivalent to like a 3,000 some odd bit key for RSA. So even though it's a 128-bit key, that's still a very large key size for normal encryption for ECC. Diffie-Hellman and El-Gamal are used in key exchanges. They're key exchange protocols, although El-Gamal can also be used for encryption and digital signatures. El-Gamal is actually a derivative of Diffie-Hellman. Those are the four primary algorithms you'll see tied to asymmetric, and they're all blocked, by the way. They're not stream. Again, the only streaming cipher you'll see mentioned is RC4. So that's just a quick down and dirty on the algorithms that you might see on the exam. And keep in mind that the CEH exam is not going to test you extensively on cryptography. It's more going to test you on which types of cryptography and how you might break that cryptography, which ones are weak and how you might break them. So that's basically the extent you're going to see in cryptography on the CEH exam.